Okay, so here we are with the anesthetic machine that now you know all of its components and all of its parts and its functions. So what we're going to do now is test our machine, get it ready for use. In order to do that, we perform a 10-second leak test, or what I like to call a 10-second leak test. Some books will talk about performing it for 20 seconds, even up to a minute, but to be honest, within 10 seconds you'll know that there's a leak in your system, and I'm going to show you how to do that. Before starting the 10-second leak test, or leak test, you want to make sure that we have verified our source of oxygen. So let's look down here. So with these we have the E-tanks, and we have a manometer here that's reading almost 2,000 psi. Now, don't let that fool you. Just because the reading says 2,000 psi, it doesn't ensure that our tank is open. What can happen is that someone can close out the tank and not flush out the oxygen that is trapped in the system, and so this reading will continue to read high even though the tank is actually shut. I have to verify that that's not what's going on here, so the first thing to do is to depress my O2 flush and see what happens with this needle. If when I press the O2 flush the needle starts dropping, that means that I was actually only dealing with the pressure that was trapped in this area here. However, if when I press this button the needle stays up, that means that my tank is in fact open and that I'm ready to go. So let me go ahead and push the button and see what happens. You notice it's dropping. So I push the button and sure enough the oxygen level is dropping. That means that my tank is actually shut, and this was only the amount of pressure that was trapped at this manometer. Okay? So that's good information to know. This also highlights the importance of making sure that after I am done with the day with my anesthetic machine, I close my tank, that I go ahead and release any air or oxygen that is trapped in the system. By releasing the oxygen trapped in the system, I make sure that I get rid of this ghost reading that's on there, and what that'll do is ensure that the next person that uses the machine is not fooled by that erroneous reading. Okay? So I'm going to go ahead and release all of it, and I know that this was the ghost reading and not the true reading of the machine. So let me go ahead and now open my tank, and notice that when I open my tank the needle goes right back up. I can press the O2 flush all day long and my needle will not drop. Okay, so that's what you want to do by verifying your oxygen source. Okay, so now I've verified my oxygen source. I'm ready to perform my leak test. Before I do so, why don't we talk about the common areas for leaks. So the first, or the primary area that you may have leaks is around your bag. So this is the reservoir bag. Remember that you change these out based on the size of the PET. So here we have a 2-liter bag. The most common area for having leaks is right around this rim here, right at this where it goes from rigid to soft. Okay? For that reason, it is important to always handle the bag from this hardy rubber rim rather than down here where it's soft and easily breakable. Okay? So the most common mistake I see is technicians holding the bag down here and applying it like this, when you really want to apply it around this rim like this. The other part that I see is technicians will pull on the rubber bag here, and again that makes this area prone to micro tears and rips, whereas if you pull from the rigid rim you're less likely to affect that area. Okay? So that's the first area that is most commonly prone to leaks. The other area that's most commonly prone to leaks is your circuit. So because you're changing these out every day, your breathing circuit may leak around the edges of this corrugated tubing. These plastic tubings may become worn and used, and they can start cracking and breaking, and so all of this tubing is prone to leaks. Beyond that, you can also leak at any of these connectors or hoses, these white pieces, any of these screw valves, and also at your flow meter. Another area that's common is your inlet and outlet of your vaporizer. So all of these component parts, if they are leaking, most likely you would have to call out a technician to come and service the machine as a whole. If your flow meter is leaking or suspected of a leak, you would call out your technician. If your vaporizer inlet and outlet are leaking, you'd call out a technician. However, for the bag and the rebreathing circuit, that's easy enough to switch out. So if those are the sources of your leak, then that's something that you can repair quickly, switch it out to a new one, and hopefully resolve your leak. And this is why we do the leak test. Okay? So, we're getting ready to start our leak test. The first thing to do is to plug up any possible escapes of O2 or gas. And so the first one that comes to mind is my positive pressure releasing valve. So I want to close that out. That's also sometimes called the pop-off valve. I want to go ahead and close that out. Okay? That closes my scavenger, so I can't leak O2 or oxygen or air out of my scavenging system. The second part or source of a escape for the gas in the system would be the breathing circuit, right? The end of the breathing circuit where the patient's going to be breathing. So I want to plug that up, and I go ahead and plug that up with my thumb. Okay? So having closed my pop-off valve or my positive pressure releasing valve, having plugged up my breathing circuit, I now should have a completely closed system and ready to perform my leak test. To perform my leak test, what I do is I flush the system with oxygen and fill the reservoir bag. You will see the reservoir bag fill up like a balloon, and you will see the little creases on the corners of the bag disappear. So let me start that now. So notice here I have creases in the corners of my bags. I'm going to keep going with my flush until that disappears. So I'm looking for that visual cue. I'm also looking at the reading on the manometer. I'm wanting to ensure that I'm over 40 centimeters of water of pressure on my manometer. And that's in fact almost at 50 there. Okay? Next thing I want to do is open my flow meter to about 0.2 liters per minute. That ensures that there's no leak in my flow meter system. And now I count to 10 seconds. 1 1,000, 2 1,000, 3 1,000, 4 1,000, 5 1,000, 6 1,000, 7 1,000, 8 1,000, 9 1,000, 10 1,000. I noticed that my needle did not drop. It held its pressure. The bag did not deflate. I did not get my creases back. So therefore, I have successfully performed my leak test. And I can go ahead and close my flow meter, and also I will simulate what a leak would look like. If I had a leak with my thumb, you can see that the creases would come back and that my needle would drop. Okay? So that I don't have a leak. Now it's very important that after I complete my leak test that I open my pop-off valve or my pressure relieving valve, because if I keep that shut, it's going to create a lot of positive pressure in the system, which would be damaging to my patient's lungs. You can kill your patient by keeping this closed after the leak test. You need to open that back up for use. Okay, very important. Second point that's very important is that I want to make sure I don't complete my leak test, go back to my oxygen tank and close it. I don't want to close it. I want to keep that open because that was the whole point of my leak test. I'm now ready to go and ready to move on and work on the patient. If I close this out, I have to start all over and perform another leak test. Okay? And with that, we have completed the leak test and are ready to use our machine.